So you're new to programming. You think Python is the name of a snake, Java is a coffee delivery service for programmers, and you have no idea what an algorithm is. But fear not, as we go along today, you'll come to realize that you might be more familiar with the ideas of programming than you thought you were, and you'll come to realize that they actually lie underneath a lot of common tasks in our day-to-day lives. When we talk about programming, the heart of programming comes down to problem solving. Now, there's a bit of limitations with what computers are really good at versus what humans are really good at. Give us a list of numbers, ask us to memorize it, we'll forget. Show us a bunch of emotions, and we're better at dealing with that. Tell us to build logic, we're better at dealing with that. Granted, with the growth of AI, maybe we're not as good at those other things as we thought we are, but the point still stands that computers are really good at certain things. And as part of being a good programmer, it is important to recognize what those things are and how you can convey those problems to a computer so that they can help you out with that. I'll be using the book ThinkPython, the second edition, as a source material for these videos. So let's get straight into chapter 1. Again, we're talking about how problem solving is very important for computer scientists. And hopefully, as you go along building your own programs, you'll not only get better at coding solutions, but you'll get better at solving problems without code because you'll learn more algorithmic approaches. And when I say algorithmic, basically the idea is you'll learn how to break a task down into steps. And the point of breaking it down into steps is that you can guarantee that you'll eventually get to an answer. Now, even when we're talking about algorithms, there's efficient algorithms and inefficient algorithms. Algorithms which require you to remember a lot of things, or algorithms which require a lot of steps. But for now, we'll just deal with basic algorithms, so that's not too much of a concern. So what is a program? Well, firstly, for a program to work, it's going to need to do some amount of processing. But to process, it needs data to work with. So usually you'll be working with inputs, which might be data that you'll get entered by the user to the keyboard. Maybe it's a file that your program links to. Maybe you'll even be using some online web services to get your data. Now, once you have data, you might want to do some maths on it, maybe add, subtract, multiply, and maybe you don't always want to do the same thing. Sometimes if a number is even, you do one thing. If it's odd, you do another. So that comes under conditional execution. And sometimes you might want to repeat a step over and over until you get the desired result or up to a certain amount of times. That comes under repetition. And once you've done the processing on your data, you're going to want to output it. And when we say output, we just want the answer to be shown to us on the screen so that we can use it for ourselves. And there you go. Now you've covered a majority of what programming is, breaking a problem down into input, processing, which might involve maths, conditional execution, repetition, and an output. Obviously, we'll be using Python here. So what is Python? It's an interpreted language. And when we say interpreted, that's a complicated word for now, and you don't necessarily have to get into it. So we'll just leave it at that. If you want to look it up, feel free to do so. You'll have to install it, and I'll try to add a link below to where you can install Python from. But once you've installed it, what you can go ahead and do is press Windows R, type in CMD like I have here, and then press enter or OK. And this is going to load up a black box. Some of you may have already seen this at some point. It's a very scary thing and it's hard to navigate, and this was kind of what computers were like back in the day. But don't worry, we're not going to be dealing with this too heavily right now. What we're just going to want to do is, after we've installed Python, what we're going to do is type in Python here into our command line. And what this does is it loads up the Python interpreter in our command line. Now what's going to happen is Python is a programming language. What a programming language does is it takes instructions and executes them. So what I can do is I can tell Python to add 4 and 2, and it'll do that for me, and it'll give me 6. Notice that one line has these 3 lesser than signs. This is known as the prompt. This is where you write your code. Now, I just wrote 4 plus 2, but your code can get more advanced. For example, you could type in print hello world. And what this does is it outputs hello world. The line without the lesser than signs, without the prompt, is your output. Speaking of hello world, that's one of the most basic programs any programmer writes. So if you just put this into your command line, you've officially written your first program. Now, one thing to keep in mind is that computers are really good at computation. I know, big shocker. I was surprised too. But basically the idea is they're really good at maths. And so if you ever have a maths question, you can just put this in. Now 4 times 8, it's 32. Put in 6 divided by 6, that's 1. Put in 3,000 divided by 2,000, 1.5. It's really, really fast, and regardless of how complicated I make this, it's still going to give me an answer instantly. So let's just get familiar with the signs here. So we obviously have plus for addition, minus for subtraction. For multiplication, instead of the X symbol, we have the asterisk. Why that is, I'm not completely sure, but it's probably because X is a letter and we didn't want to get that mixed up. Then we also have slash for division. But that's not every type of computation you might want to do. Sometimes you might want to do power, for example. Now, if I want to do 2 cubed, I can do it like this. That's okay, that's not what I was expecting. Indentation error. Now, this is a good thing to come up right now, but for now, for just a second, I'll ignore it and we'll remove this space and it'll work perfectly. And you can see that the program is raising 2 to the power 3, and that's great. But what if I wanted it to raise it to a decimal power, like square root of 2? Now I can't do that with the multiplication symbol. There's just no easy way for me to do that. So we do have a way to raise something to a power of another. In Python, that's represented with double asterisks, and in fact, in a handful of other languages, it's the same. And so now if I do 2 to the power 0.5, I'll get 1.414 blah, 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 blah. Now, you realize that this is roughly the right answer. But if you're very pedantic about it, you'll realize that this isn't perfect. In fact, there's probably some inaccuracies, and let's see if we can catch those. Okay, I'm somewhat regretting going with 2 because the computer works in binary, and what binary is we'll get into a minute. But that might be the reason why its square root 2 answer is very accurate. But if you look at the last digit, we have 1, and it's actually supposed to be 0488, which means it should have rounded down to 0. So we do see that this does give some inaccuracies. Now, we just touched upon the fact that computers work in binary. And binary is a weird, wacky thing when you first hear about it. Basically, the idea is that when we write numbers, we do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And the question is, what if I did not have 10 different digits? 10 because you're also including 0 as a digit. What if I did not have 10 different digits to work with? What if I wanted to say a number in just zeros and ones? Now this is purely a maths exercise, but let's say I had 10 empty positions and they could be either on or either off. So since each position has one of 2 states it can be in, the first state can be in any of 2 states. The second can be in any of 2 states, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. The point I'm trying to make here is I could represent 2 to the power, I'm using double asterisk for power, 2 to the power 10 different combinations of on and off states. So if there was a way I could link each combination with a number, I could represent 2 to the power 10 numbers. And that's basically the idea of binary. Now, I would recommend you to watch a video on binary number conversions because it's a really handy thing. And if I get the chance, I'll try to make a video on that as well. But for the time being, I would highly recommend you to watch a video. Now, in some languages, as they've mentioned here, this symbol, also known as the caret symbol, is what's used for exponentiation. But in Python, it gives a very wacky answer. And now, this wacky answer has to do a lot with how computers represent numbers. As we were talking about before, computers only work in binary, meaning they work in on and off states. So for example, 6 is written as 1, 1, 0, and 2 is written as 0, 1, 0. Leading zeros are arbitrary, you don't have to mention them, but just to keep things tidy and matched up, that's why I've made both of my numbers have 3-digit places. And now what the computer is doing here is it's checking if these two are of the same state, then write a 0. Again, they're of the same state, write a 0. But if they're of different states, write a 1. And now this number, what we'd normally read as 100, in binary it represents the number 4, and that's why you're getting the answer 4. This is what's called a bitwise operator, and it's a XOR operator, and you can look into that if you're interested. Now, while computers are really good at working with numbers, they're not limited to it. And that's what makes them very handy. They can work with other, what we'll call data types, like strings, and a string really just meaning words or sentences. Or to be more specific, a string is a string of characters. It's a continuous list of characters. It's like if you had a necklace and each bead was representing a character. And since they've been strung together, they're called a string. Now, in the world of programming, it's very important to understand what data type you're working with. Whether you're working with a string, or an integer, or a boolean, or a floating point. What each of those are, we'll get into a second. But it's very important to understand their different uses. For example, if I have two integers, let's say 3 and 4, I can add them, I can multiply them. But if I have two strings, let's say hi and let's say Musab, notice the quotation marks. This is how a computer identifies that something is a string. But the point here is, if I tell the computer to subtract these two strings, it's not going to know what to do. And so it's very important to keep in mind that some operations work with some data types and others work with others. Now, as I was mentioning before, these quotation marks are really important. So if I were to write something like 3, but I write this inside of quotation marks, this is not an integer. This is a string. That goes for other data types as well. So there's this Boolean data type which has values true and false. Now you might be tempted on looking upon this to add quotation marks around them because these appear to us as words. Now you might not spot the error right away when writing your code, but it's going to lead to some funky behavior. And what's really interesting is that if you said a condition is true without quotation marks, or if you said a condition is false but with quotation marks, these are going to end up evaluating to the same thing. And that's because of these quotation marks. So be very careful with that. And other than that, you have floating points. Now, floating points just represent your decimal numbers. For example, 0.67, 3.3, 5.8. And it's very important for a computer to know which data type it's working with, because the same binary pattern for different data types might give two wildly different answers. If you're ever concerned what is the type of your value, you can always encapsulate whatever value it is inside of a type function where your value goes in here. Now keep in mind, if you're working with a string, you want to add the quotation marks. And if you're working with a number or with a Boolean value, you don't. Also be very careful not to put commas when working with integers. However, if you're really tempted, you could use underscore just to make your code more readable, but there's no limitation on underscores. You can have an underscore every other digit. So just do what works best for you. Finally, what is a natural language and what is a formal language? Well, natural languages are just how we normally speak. They're not very exact. In fact, a lot of sentences can have different meanings. Formal languages are much more systematic. They have very precise ways of representing information. Programming languages are types of formal languages. They're not the only type. For example, you have maths and you have logic, and there's different languages inside of chemistry to represent different structures. But the main point is that formal languages give us a way to represent one thing in a specific way to make our meaning clear. The downside to this is that we might end up facing something known as syntax errors. You're going to encounter these a lot, and so it's very important to get used to them. But one common example we can work with is that instead of 3 plus 6, I instead write 3 brackets 6, and it's going to give me an error. Now, in this case, it says unmatched right bracket, but if we look to the left of that, it mentions it's a syntax error. That's because I'm not following the rules of the language. When we talk about rules of the language, there's also like if you have a print statement, and if I write print hello, it's going to give me an error because whenever I'm using a print statement, it needs to be encapsulated inside a bracket. Going back to what we saw earlier, if I were to write 2 to the power 3, it's saying indentation error. Now, it might be a bit misleading and you might think that there's an error here, but the actual error is this space that was added at the start. Most languages don't have this, and you might originally look at this as like a bad thing, but Python is very space sensitive, at least at the start of your statements. So be very careful if you accidentally ever leave a space. It's okay if this happens to you. Many programmers have lost their sleep over this. It's perfectly fine to make mistakes, but do be wary of that. And with that said and done, just know that in programming, you're going to face a lot of errors and you're going to have to do a lot of debug. What debugging refers to is getting rid of those errors in your programs that are stopping your program from doing what you want it to do. A very famous quote is that 10% of the program is actually writing the program, where 90% of it is debugging. And as your programs get longer and longer, you start to realize that that is very spot on. And the only way to get better at debugging and better at avoiding errors is by making errors and practicing. So don't be afraid to make mistakes. To conclude for today, I just like to give you tidbits of information which might help you when you're doing these exercises at the end of the chapter. So a print statement is written like this, and whatever is inside of this print statement gets written out, gets displayed to the user. For example, print hi. Make sure to include both of the brackets. These brackets in specific are called parentheses, whereas these are square brackets and these are curly brackets. Make sure that if you're writing a string, you write it in quotes, but if you're writing a number, you can write it without. If I try the same thing for a word like hi, it's going to give me an error. It's going to say hi is not defined. What that means, you'll understand better when we deal with variables, but for now just understand that characters need to be encapsulated in quotation marks. And keep in mind that a single asterisk represents multiplication. But that's all, and I hope it was useful for you. Best of luck programming!